Well, like Luke said, I was a fish biologist for WDFW, Game Department, Wildlife, whoever it was, depending on the era there. And I think today is the first time I've ever been called a professional. I was a boot biologist, spent lots of time in the North Sound rivers, and especially on the Skagit, Sauk, walking the streams. I'm also an avid angler. I agree with Bill's comment earlier in the day that often anglers bring a different and sometimes more complete perspective to some of our resources than some of the biologists. I like to think that I'm a hybrid of both, and it brings maybe the worst of both. I'm hoping the best of the both to some of the discussion. I've spent many, many days on the Skagit. I've been over, between bull trout work, cutthroat work, and steelhead work, over substantial portions of the basin, seen lots of it. What I'd like the folks from this meeting to take home, something to think, would be to recognize that Omicus in our anadromous rivers are very complex animals with really complex potential diversities, behaviors, and strategies. And a robust population requires all of that. What I've seen in the Skagit Basin is that basin captures as much of that diversity and differences in behavior as any basin in Puget Sound. The second thing I'd like people to bring home is that steelhead, because of their extended life histories, have huge habitat demands. They have very specific demands on very specific habitats at each of their life stages, from egg to smolt. A newly emerged fry needs different kind of habitat than a par needs during the winter, or that a smolt may need during the last winter it's in the river. They spend 2 to 3 years in the river and need a lot of diverse habitat. And it's much more than just the amount of habitat or the length of habitat that they need. It's very specific quantities of it. So, it's very misleading to just look at linear habitat. And I don't think those of you that fish a lot up north have to go no further than Deer Creek. The amount of habitat, the length of habitat in Deer Creek on the North Fork of Steelhead has not changed at all. But I think our steelhead productivity has changed substantially, and it's because habitat has changed. And any discussion in recovering habitat, and under the Myers over there, that habitat extends well beyond the mouth of the rivers to west of the international date line and back. Any discussion on recovering steelhead should look at all those factors. And finally, I think we need to recognize that the Skagit Basin is an incredibly complex basin with some of the most spectacular species complexes and diversities to be found in the state of Washington. And that complexity in both in habitat and species diversity really shapes the populations within that basin. I know, just some of the complexities you find in that basin. Outside of the steelhead world, you find adult coho returning to the Skagit Basin from late June until probably January, spawning from October through early April. That's something you just don't see many places. You got Chinook returning to the basin every month of the year except probably November, December, and January. Steelhead, we got adult steelhead, winter steelhead returning to the basin from late October, Steve, in the test nets through early June, spawning from late February, early March, clear into the last week of July. You got steelhead returning as 2-year-old jacks to 8 or 9-year-old adults. You had an extremely robust sea run cutthroat population, a pretty spectacular bull trout population. For decades, the Skagit River was ground zero for chums and pinks in Puget Sound. There was a time not too many years ago that over half the pinks returning to Puget Sound came back to the Skagit River. And I know of no basin in probably south of the U.S. border in the United States that has more abundant and diverse anadromous species than the Skagit River. And because of that diversity and species, there's a lot of partitioning of habitat. Some of the habitat is more suited for cutthroat than it is cutthroat, and the cutthroat will than steelhead, and the cutthroat will dominate. Others is more suited for coho than steelhead, and the coho will dominate. And as long as you have those species coexisting together, you're going to have that partitioning of habitat. The end result is that defines the population, results in a more robust population, a more diverse population, but it limits what each of the populations can do in terms of overall abundance. In basins like the Skagit, and given the steelhead's juvenile rearing habitat requirements, the amount of spawning gravel is not the limiting factor. It's almost never the limiting factor in almost all of our anatomous steelheads. Now, I can think of a couple exceptions, but generally speaking, the amount of spawning gravel is not the limiting factor. It's some other freshwater habitat or marine water. If we can just remember those three things, I think you go through with a reasonable foundation to begin thinking about where we go in the future to recover Skagit steelhead. I've been fortunate enough in my career I had the opportunity to sample any fish that interests me, and I could, if I encountered an oddball Omicus in the system, I could pull a scale off of it without having to worry about federal permits and all that kind of stuff. Look at its life history. I encountered a steelhead that an angler had caught, and I wanted to know what its sexual maturity was. I tell them, hey, I need to clean your fish. I can find out whether that fish is ready to spawn, is it months from spawning, those kind of things. And with that fortunate ability, I gained some significant, what I think are significant insights into some of the diversities and behaviors that our steelhead populations and all the fish in the Skagit River exhibit. We find Skagit steelhead spawning from basically Cedar Woolley in the main stem Skagit to 115 miles upriver and to 3,000 feet elevation. Some pretty significant spatial distribution. What I really like to do, though, is I've spent a lot of time up there, and I just like to get at some of the things that you guys are most interested in, and I'll try to field the questions as we go along. It's, as I get older and older and my senility advances and my brain becomes more Swiss cheese-like, the opportunities to glean anything from this muddled brain of mine is probably decreasing, so grab it while you can. I'd be more than happy to field anything where you want to go. Although I would just soon not talk about Chambers Creek fish. We're talking about the future of the Skagit River. We know what that is. It's not going to have Chambers Creek fish in it. Let's move forward and go onwards that, unless that's a driving issue for the guys here. Questions? Issues? Answers? Concerns?
Bill
sure.
mentioned the lack of fish in the Cascade. Talk about the Cascade.
It's interesting. And in fact, I just had a conversation about that with Brett Barkdahl, the manager, a couple 3 weeks ago. We were talking about some of the early spawning, and he mentioned the difficulty in catching those fish up there. But every year they find reds, and quite a few reds in the Cascade. And so I'm not sure what the mechanism is that makes those fish difficult for the anglers to find. But the end result is that when they look, they find reds. When I was looking to do some genetic work up there and poked around with electroshockers, I found juveniles Omicus pretty commonly in the basin. When they sampled those Omicuses and ran the genetics on them, they were very similar to what was found in the wild steelhead populations elsewhere in the basin. I don't know why you don't find them, but there's certainly wild winter steelhead making it clear up into the forks at least of the Cascade, north and south fork of the Cascade. I think stuff like that is what makes steelhead so darn fascinating. Is we don't have all the answers and don't understand all the things that are going on, but yeah.
In your opinion, what is the carrying capacity of the Skagit watershed for our wild steelhead?
For wild steelhead?
Yes, sir.
First of all, we need to talk a little bit about carrying capacity. Carrying capacity is the ability, in the case of steelhead, typically in fresh water, is measured by the ability to produce smolts. And the ability for a basin to produce smolts will vary, in some cases, dramatically from year to year. A year with low water, for example, if the limiting habitat is low water rearing, if we have a drought like we had potentially we'll have this year, it'll produce less smolts and the capacity will be lower. If we have, if some other factor is a limiting factor, then the carrying capacity. So it's a moving target. It varies from year to year. What people generally talk about is what carrying capacity is on an average condition over a given period of time. In the case of the Skagit, there's pretty good data on what the wild steelhead escapements have been and the resulting run size have been since 1978. That data indicates that the carrying capacity is something around 9,000 fish. Every time that there's been runs seen in excess of about 9,000 spawners, the resulting recruits, the number of steelhead that those spawners have produced is less than 9,000 fish. Washington Trout, now Wild Fish Conservancy, hired a Bayesian mathematician to take a look at the steelhead spawning statements data on the Skagit in, I think it was about 94, 90, somewhere back in there. And she looked at all the data on the Skagit and ran through the analysis on that. I don't pretend to understand the numbers that went into that, but what she reported was that her estimate was that carrying capacity was somewhere between 8,000 and 9,000 fish. MSY was around 4,000 fish. Indications are that since the mid-90s, those factors may have gone down a little bit as a reflection of lower marine survivals. And we can get into why marine survivals affect freshwater carrying capacity, but it does. Did I get to your?
Yes. Thank you.
Sure.
How much habitat restoration has been done in the Skagit in the past however many years, and has the habitat restoration added to the carrying capacity and the escapement models?
Well, I don't know exactly how much restoration work there. There's Steve Hinton's here. He probably could talk in more depth. The largest focus to date on, well, there's two pieces to the restoration. One has been a lot of land acquisition that protects stuff from, for future benefits. And in many ways, that might be the most sane strategy for long-term benefits. But there's been some habitat manipulations attempting to restore stuff. I think the primary, would it be fair to say the primary focus has been on the estuary?
Yeah, the primary focus has been around Chinook.
Around Chinook, yeah. And it's been mostly in estuarine areas, and hugely valuable and important for Chinook production. Has almost zero benefit for steelhead. The average wild steelhead in the Skagit River spends 3 to 5 days in the Skagit estuary. A couple days moving out as a smolt, and a couple days moving back as an adult. They would probably survive just as well as if it was a concrete shoot, but that's. But that there's more work upriver. The Skagit is fortunate and is one of the few basins in Puget Sound where a majority of its headwaters are relatively intact. Most of our basins have unwound from the tops down. In the Skagit, we got pretty good headwaters. There was estimates made with bull trout, which spawn in most of those headwater areas, that about 80% of the critical bull trout habitat, the areas that they spawn in the juvenile's rear end, was in pristine condition, which is unique. And I think that's one of the reasons you tend to find more robust anatomous fish populations in the Skagit than you do in most Puget Sound rivers. And that's the commonality is across all the species. Yeah.
I understand we're talking about Puget Sound rivers, but why are we focusing just on Chambers Creek? Do the Skamania hatchery fish have some of the same issues that?
There's many of us that would argue that the Skamania stuff are probably more detrimental than the Chambers Creek fish. Yeah. They're much. The evidence are they're much more likely to establish natural reproducing populations. The progeny may be more successful. There's several examples of Skamania fish colonizing, establishing naturalized populations in Puget Sound. Off the top of my head, South Fork Skycomish and Green River come to mind.
And then the other question that I have is, how the hell did we end up with a new hatchery on the Elwha? Is that considered part of Puget Sound? It's
considered part of Puget Sound. That's the westernmost terminus of Puget Sound, basically, is from Elwha in. Why there's new hatchery on there, I way beyond my scope. I haven't spent any time out there. All I know about it is exactly what you've read. There's probably some people talk about that. I probably know a little bit more about. Hope I know a little bit more about the Skagit and its steelhead. Sure.
You talked about the headwater habitat qualities of the Skagit system and how those positively impacted bull trout and other fish species within the watershed. I've always been impressed with the rainbow, bull trout, cutthroat, and other non-salmon or steelhead fish populations in the Skagit. Is that also a result of their food supply, or are there other beneficial factors that have led to that, or what makes the Skagit unique? I mean, I see so much more than you see with Skycomish or other local watersheds.
Well, and part of it is because the headwaters are more intact. so that much of that's available. Some of the, it's got a relatively robust management system across the board, although to be fair, the most conservative managed species in the Skagit Basin is probably steelhead. Yet they're probably the least common in the basin. Some of the reason that cutthroat are doing so well, the reason the bull trout are doing so well is because of the intact headwater streams that they're required on. One of the reasons that the cutthroat are probably doing so well is I talked earlier about how the various species partition habitat. The cutthroat, the sea-ring cutthroat in the basin are found in the lower, low gradient tributaries. 95% of the cutthroat are found downstream, using tributaries downstream of concrete, for example. As we've, as we logged and developed all those watersheds, we've changed the hydrograph and we've converted much of the mileage of those tributaries from streams that were cutthroat, coho, steelhead complexes to streams that are more cutthroat and coho complexes. And so we, as we've altered those, we've reduced the potential for those streams to produce steelhead, but we probably at the same time increased the potential for those streams to produce cutthroat. We saw something very similar to that in Lake Washington. And it went one step farther in Lake Washington, is it, it reduces, the development went one step further in the tributary streams. It became essentially all small streams and cutthroat streams. Typically what you find in a low stream is the cutthroat dominate the habitat where you can step across the creek without getting your feet wet. That's where you find the cutthroat. As the stream gets a little bit bigger and you see riffles and pools forming with large woody debris and stuff, you tend to find a lot of coho. As the stream gets a little bit larger, the flow gets a little bit bigger, a couple of streams have joined together. You start seeing more runs, glides, and larger pools with less woody structure and stuff, and those are the habitats that juvenile steelhead dominate in. And as we've changed the low elevation streams, we've changed a lot of those streams from cutthroat to steelhead streams. That makes sense?
So does that then state that with proper habitat restoration, you could move those streams back to kind of historical characteristics too?
Sure. I mean, that'd be part of, one would hope that would be part of restoration work is trying to restore some. Unfortunately, in restoring the hydrographs of some of these low gradient streams would mean revegetating with timber stands that are a couple hundred years old, probably getting rid of all the residential whales in the basins and a number of other actions that society probably isn't real anxious to undergo. But it's feasible, probable? No, I don't think so.
Do you think that the diversity with somewhat of the decreased numbers of fish that have returned to Skagit in recent years, do you think kind of life history diversity still remains? That's still intact? I think that's been,
from what I've seen,
away.
They may not be in exactly the distribution of diversity we'd like to see, but the seeds of that diversity seems to be largely intact. I still see wild winter runs returning in the basin from November through June. We see some diversity in spawning. In fact, in many cases, the diversity of Omicus in the basins increased dramatically in the last 5 or 6, the last 10 years, 8 years. In 2008, a substantial portion of the Skagit Basin was set aside as essentially wild salmon or wild salmon management areas, egg banks, gene banks, whatever you want to call them. All of the Sauk, all of the Cascade but the lower 2 miles, and all the main stem Skagit above Marble Mound has since 2008 have been managed under selective gear, catch and release for all species, no hatchery fish planted, and the only fish you're allowed to retain is a hatchery steelhead. Starting in 2010, all the tributary streams were closed to all fishing unless specifically opened. Most of those that were reopened were opened with some sort of restricted regulation. Probably, last time I looked at it, about 70% of the 209 miles that steelhead spawn in are under that kind of protection. I would argue that the Skagit has some of the largest, currently has the largest wild salmon management zone or gene bank, steelhead gene bank anywhere in the state. And the remarkable thing is that you're seeing some really positive benefits from it. In 2012, which was 4 years after the Sauk went under this management, in my 10 or 12 days of fishing the basin, I caught 22 resident rainbows that were from 14 to 22 inches in length. To put, I thought that was pretty remarkable, but to put that in context, in the previous 30 years of fishing the Sauk, I hadn't caught 20 of such fish. I think, you know, more importantly, what's really interesting is I fish the Skagit a lot for cutthroat and stuff. The last few years, I've been catching 18 to 22-inch cutthroat as far down, or rainbows, resident rainbows, based on scales, fish that are 6, 7 years old, as far downstream as Burlington. And this is miles and miles and miles downstream from these areas. So we're seeing, I think, some pretty dramatic expansion of resident rainbows, which, you know, I look at the managing the species in the basin. I don't care whether it's a resident life history or anadromous life history. It adds robustness to the diversity and stability to the population's abundances. And I think, you know, what's going on in the Skagit is some wonderful news.
Yeah, Curt, you think because the rainbows, the resident rainbow are increasing, is that an indication that actually maybe the productivity is going up in the river and not so many of them migrate out? I mean, there's a genetic component to it all, but coastal habitat's not good. Why go there and stay home and do better?
There's several things going on. First of all, you know, work everywhere indicates that there's a natural ebb and flow to resident rainbow, the resident life history and anadromous life history, and you see that in all the species, and they evolved to take, you know, use different habitats, and so that some of that is just natural. We're just seeing a return to what may be a more natural distribution in life histories, because for the first time in a century, that life history has been protected in the Skagit Basin and some of these other areas, which I think is really critical. The resident rainbows are probably doing a little bit better in the steelhead in some respects, in that they're more able to utilize some of their food resources in the Skagit Basin than steelhead are. Steelhead, for example, the last 2 months there's been, you know, in this time of year, you know, there's substantial numbers of chum and pink fry leaving the basin. The resident cutthroat, or sea run cutthroat, resident rainbows, bull trout can utilize those fish. Most of your steelhead par and pre-smolts are still in their wintering habitat, you know, tucked away and safely out of harm's way, and have really limited access to those sorts of things, so that the cutthroat or the rainbows are able to utilize a different food source. Additionally, because they don't, I think they can use some habitats that steelhead can't use, in that because they're bigger, stronger fish, and some of the habitat that won't produce steelhead smolts or low levels of steelhead smolts will support rainbows, and we, you know, just all around a much more healthy situation. John?
Yeah, you said that you don't think the steelhead used the pink much, but I know Joe Anderson's recent work has shown a clear pattern where steelhead smolts are significantly larger in pink salmon ears than non-pink salmon ears, clearly indicating that they are taking advantage of those pink salmon nutrients.
Oh, they take advantage of the nutrients on a seasonal basis if it's in the system. I don't know that they feed much in the Skagit per se, in particular. By the time the pink spawn and the chum spawn in the basin, the water temperatures are dropped, and most of the par are going into wintering habitat and are about to take advantage of those things, whereas the resident trout would be out there doing that. And the same thing happens in the spring year in the Skagit with its spring flows and stuff. Those fish don't get much of a chance to get, you know, the only chance that a smolt has to use that resource directly is during its migration period, which is a relatively short window.
So how would you explain the pattern? Because if it wasn't direct consumption, the pink salmon nutrients don't go away after 1 year. There's clearly studies that indicate long-term production.
What basin was that in? I'm not familiar with it.
Skagit.
Was it? Okay. I see really big differences in the smolt size in sea run cutthroat, for example.
Yeah, but they found it was steelhead too, which is clearly indicating. And what I thought was interesting is we talked about marine survival, and one way to increase marine survival is to have larger smolts. And so, obviously, I think something we haven't mentioned here, which is the need to increase probably salmon escapements to benefit a fish that spends so long in fresh water. Increase its size. I mean, the potential is that we've seen it.
There's absolutely no question that the more marine-driven nutrients we can capture in these basins, the more robust all the population is going to be. And that's one of the huge habitat factors that we're missing in many of the Puget Sound rivers, and in this case the Skagit itself, is we've lost the channel complexities to capture those carcasses in the basins. You know, the only year, 2001, we had an exceptionally dry winter, and there was chum carcasses captured in the basin all winter. Bull trout were still feeding on chum flesh at the end of February. And they derived huge benefits from it. The bull trout exploded, the cutthroat did well. I'm assuming that, that there was benefits to everybody across the board. But that's an anomaly. Most years, some cases, the chum carcasses are gone within weeks of the time they spawn and they're washed out to sea. It does wonderful things for Puget Sound crab, but it does diddly squat for our fish that we're concerned about.
Now, I don't want to clarify, but this study has shown over a 6-year period that the alternating years, that it doesn't agree with what you told us, that steelhead don't use those nutrients.
It's not a black and white thing, and they do use it some, and there's no question about it. But they have limited access to it just because of their behaviors.
But if it was limited, you probably wouldn't see that strong response, and it's from the department in the Skagit River.
It's crazy, Curt, because I've got the information I took out of in my research on my part of the Skagit project. There's a very clear response by both 2 salt steelhead and 3 salt steelhead. Looking at the scale samples I was provided, there was a very definite positive response to the pink salmon years in both 2 or 3 salt. For the out-migration years,
I'd love to look at it.
Definite positive response to pink salmon spawn.
I'm not surprised that there's some response. I mean, every anadromous fish in Puget Sound has an even odd response to pinks. They're just such.
Absolutely clear.
And to get back to me afterwards, I'd like to see the author.
Just a couple more questions.
Sure.
So Curt, I'd love to hear your thoughts on the impacts either as an area or the hydrograph dams.
The dams? Well, obviously the Baker dams are huge. We've chopped off, 15% or so of the historic.
I think it is 15%.
I'm just off the top of my head. I don't recall the numbers exactly, but I think it's in that number. Dave might have a better number on it, but it's a significant portion of that. The Skagit projects on the city lights, Skagit projects above New England probably had virtually no impacts on the distribution of steelhead. It's pretty clear that very short distance upstream of the powerhouse there's probably velocity barriers in the bypass channel. That said, the fact that the city of Seattle Light has to pay, undergo a lot of mitigation actions, there were impacts to those fish in terms of how the flows are, dealt with. We're looking at unnatural hydrographs. We're looking at unnatural daily fluctuations in flows. If it's not a natural system, I've got to believe there's some impacts to that. And there's people, we can argue about exactly what those impacts are, but there's certainly cases. We don't seem to find near the par in say, between New Halem and Marble Mount that we might find, say, in the Sauk. How those projects may be contributing to that is not known, but it is an interesting question. Sure.
When the wild steelhead populations on the Skagit were at their lowest in the early 2000s, what were the limiting factors? And what has changed since then?
In 2005, we saw escapement in the Skagit Basin of 2,500 fish, 2,508 or some such number as that. And the driving factor in that was probably multiple factors. The dominant factor by far, I believe, was the impact from the 2009 was the low escapement. It was 2005 fish. It was 2009, I misspoke. The dominant factor was the big flood we had in 2003 in the Sauk Basin. And what happened there was a huge storm in late October 20th or 21st, that estimates are dumped 21 inches of rain on top of Glacier Peak. It did it at such time that all the unconsolidated till from the glaciers that had retreated the previous 15 or 20 years wasn't snow covered, and it washed, anybody who was on the basin, just unbelievable amounts of sand into the Sauk, and then ultimately down to the Skagit downstream of that. One of the things that had had significant impacts on where the fish could spawn and how successful they were. And those impacts carried through for a number of years. I spent a lot of time on the Sauk, and typically the majority of the wild winter steelhead in the Sauk come out of the gravel in first week in August, 10th of August, sometime in that time frame. In 2004, 2005, 2006, and 2007, and 2008, The fry were coming out of the gravel the 1st of July, before the 4th of July weekend. Basically what happens is all that fine material interferes with the inner gravel flow, and once the eggs start to hatch, they run out of oxygen, they increase their oxygen demand, and the survival forces them to jump out of the gravel, but there is a huge overall survival cost to that. And I think that the cumulative effect of those things over those years contributed substantially to that low brood year in 2009. And interesting, in 2009, we were fortunate in 2009, that was the first year that I didn't see those early emerging fry from the gravel. And fortunately, that brood year fish did exceptionally well. The scale information is in for 4 and 5 year olds from that brood year fish. And those 2,500 fish produced over 2.5 adults for every one of them that spawned, which in the steelhead world is pretty amazing productivity. When you got 2,500 fish producing whatever 2.5 times 2,500 is, 7,000 something fish. That's really good news. Since then, we've 2013, 2014, and looks like in this year the average escapement's going to be up pushing that 9,000 range. I think it was 8,700 in 2013 and 9,100 and last year. And the counts this year are way ahead of what they were the previous 2 years. Whether they're early or not, as we talked this morning, we don't know, but it'll be interesting to see.